Hello everyone. This video would focus on graphing absolute value equation in Vertex form, and this is the first part. In this part, our value of A would be a -1 and the other example would be a +1. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to absolute value equation in Vertex form. Before we jump into this example, let's have a review on the basics of absolute value equation in Vertex form. We remember that the equation for an absolute value equation in graphing form or vertex form is y equals a absolute value of x minus h plus k. Now let's go over the effects of the parameters a, h, and k to the graph of an absolute value equation. We remember that if A is positive, the graph opens upward. Now, if A becomes 0, then the graph becomes a straight horizontal line. On the other hand, if the value of A is negative, the graph of an absolute value graph will open downward. Now, we also remember that this A is called the stretch factor, meaning it makes the graph vertically stretch, which makes it narrower, or it makes the graph horizontally compressed, which makes it wider. We remember that the closer the value of A is to 0, then the graph becomes wider. So if you notice, the graph gets wider. We started from the negative side and then we go towards the 0. It becomes wider and wider to the point that if it gets to 0, then it becomes a horizontal line. This is also the same thing for the other side. So if we start from 10 right here, we go all the way to 0, then the graph becomes wider and wider up to the point that it becomes so wide that at 0, it becomes a horizontal line. On the contrary, we remember that the farther the value of A is from 0, meaning if we go towards the negative side, then the graph becomes narrower. So as we go farther from 0, it becomes narrower. We remember that the coordinates HK is the vertex or the locator point of the graph, where our H translates the graph left or right, while the K translates the graph up or down. Okay, going back to the example right here, we're supposed to sketch the graph of this y equals negative absolute value of x plus 5 plus 4. The first step is to determine the vertex or the locator point. I'm going to go ahead and write that down here. To determine the vertex or the locator point, we're going to use the HK. So this value that we have here represents the H and this represents the K. Now the rule is, so it's easy to determine the locator point. There's a trick. You are going to switch the sign of this. So it comes out -5 and keep the sign of this. That would be a +4. So our vertex or locator point is at -5, 4. The second step is to create and complete the table of values. So I'm going to go ahead and draw the table of values down here. Okay, we are going to write this vertex or locator point in the middle of these blank boxes. So we're going to go ahead and put that -5 and then 4 down here. So we go ahead and determine the rest of the values for this x values that we have right here. So we can go ahead and say we can go up to down to -6 to -4. Then that would be this -7, so that's -7, so it goes -5, -6, -7, and this is -4, and this is -3. So we are going to determine the values for the rest of these blank boxes. So we're going to show the work down here. So we're going to start with the first x value. So what is the value of y when x is -4? So I'm going to go ahead and show that down here. So x is equal to -4. So what's going on here is that we are going to plug this negative 4 into the x here to solve for the y. So our equation would come out, that's going to be y equals negative absolute value of plus 5 and then plus 4. So we are going to put in the negative 4 in place of the x. So it's not going to be x anymore, but then we have to plug in the negative 4. Then we have to do the math for this. So this would come out negative absolute value of negative 4 plus 5 is positive 1. And then that's a plus 4. The absolute value of positive 1 is 1. So I go ahead and write negative 1 because there's a negative in front of it. And then that is a plus 4. So then our y then is 3. So this is our y value whenever our x is negative 4. So we can put that down here. So this is 3 right here. So we're going to show the work for the next value of x here, which is negative 6. So that is x equals negative 6. Then we go ahead and write the equation again. That is y equals negative absolute value of whatever the x is plus 5 plus 4. So we put in the negative 6 here. And then we do the math. So this would come out negative of absolute value of negative 6 plus 5 is negative 1. And then that's a plus 4. Now, the absolute value of negative 1 is just 1. But there's a negative in front of it. So then this would come out a plus 4 as well. So our answer is positive 3. Now, please remember, because others are going to think that they are multiplying this negative and negative right here. That's not how it works, because this is absolute value. That means the absolute value of the absolute value of negative 1 is actually a positive 1. And so there's a negative in front. So the negative of a positive 1 is a negative 1. And so that's how we got 3 right there. So we put in 3 here. And then I'm going to show the work for x is negative 3 and x is negative 7 down here. So we have completed the table of values here, and this is the work right here. And so the next step is to sketch the graph of this absolute value equation. So we're going to start with the vertex. You can start anywhere, it doesn't matter. But we start with the vertex negative 5 and positive 4. So this is our vertex up here. And the negative 4 goes with 3. So 1, 2, 3. And then we have a negative 3 goes with 2, 1, 2. So this is the next dot. And then we have negative 6 goes with 3. So this is where it's going to sit. And negative 7 goes with positive 2. And this is the graph of this equation. Now we remember that if we say absolute value equation, it's going to have a like a letter V-shaped graph. So the difference between absolute value and quadratic or parabola is that in parabola it's like a letter U, but this one here is like a letter V. And so we go ahead and determine the domain and the range for this. Since this end of absolute value equation or this graph here goes to the negative infinity on the x-axis, and this one goes to the positive infinity on the x-axis, therefore the domain would be all real numbers. On the other hand, the range here would be all values of y, which is less than or equal to 4. So I'm going to go ahead and write that information up here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So the first step is to determine the locator point. I'm going to go ahead and write that information up here. Again, we remember that our locator point is HK. This is our H and this is our K. Again, the trick is switch the sign of this. So that would be a positive 3. And keep the sign of this, that's a negative 2. So our vertex is sitting at 3, negative 2. The next step is to create and complete the table of values. I'm going to go ahead and draw the table of values down here. Okay, this vertex or locator point shall be placed in the middle of this blank cell. So it's going to go down here. So I'm going to go ahead and write that as x is 3 and y is negative 2. So then we go ahead and determine the rest of the values for x here. So I go 2, and then this is 1, and then I go 4 and 5. So we go ahead and determine the value of y whenever our x is 2. So I'm going to go ahead and show that work on the side right here. So x is equal to 2, then we are going to plug this into this equation right here. So which is y equals absolute value of, that's minus 3 minus 2. Again, we put in the 2 here. So this would come out y equals the absolute value of 2 minus 3 is negative 1. And then that's a minus 2. Absolute value of negative 1 is just 1. 1 minus 2 is negative 1. So this is the value that we have down here. It's negative 1. Now let's show the work when x is 4 on the side here. So the value of 4 is negative 1 because we have 4 minus 3 is 1. The absolute value of 1 is 1. 1 minus 2 is negative 1. Now I'm going to show the rest of the work when x is 1 and when x is 5 on the side down here. So our value of y when x is 1 is 0 and when x is 5 it's 0. So we have completed the table of values. Our next step is to sketch the graph of this table of values right here. So we're going to start with the vertex. Again, you can start anywhere. So that's 3, negative 2. So that's going to be 1, 2, 3 down negative 2 here. And then the next dot is located on 2 and then negative 1. So it's right here. And then 1 on 0. And then 4 on negative 1, and then 5 on 0, and then we are going to sketch the graph of the absolute value equation that is given to us right here. And so from here, we can say that the this side of the graph is going towards the negative infinity on the x-axis, and this goes towards the positive infinity on the x-axis. So this tells us that the domain for this graph would be all real numbers, while the range, the values of y that are covered in this equation would start from negative 2 going up. So I'm going to go ahead and write that information up here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!